Welcome back everyone. My name is Sagar and we are back here with another video. So today is day 188 of our POTD series and today this question name is shortest prime path and this is given a medium level question but it is a very straightforward question, right? So you are given two 4-digit prime numbers num1 and num2. So we are given two numbers that are prime and that only have 4 digits. So it is exactly 4-digit number. So you can also see the constraints and also find the distance of the shortest path from num1 to num2. So we have to convert from num1 to num2 and we have to find the shortest path of conversion. And that can be attained by altering only one single digit at a time. So at one step, we have to change only one digit of some number. And every number obtained after changing a digit should be a 4-digit prime number. So that means, first of all, we have some number x and we have to reach y. So there should be some number of steps that we have to change. And at every step, so if we are changing from x to x dash, so if we are changing from this 1033 to some another number, so we at one step we should only change one digit. So first of all we have 1033, then we are changing this second digit, so it is 1733. So from 1033 to 1733 we have only one step, and this 1033 is also a prime number and this 1733 is also a prime number. So when we are changing any digit, so either we can change first digit or second or third or fourth. So we can, what can we do? So for one digit, we are changing from x to x dash. So there are 4 digit here, small x, x. Okay, so there are 4 digits in one number, right? And we have to change any number. So for changing one digit, how many total possibilities we have? We can place 0 to 9. And we should also not repeat our cases. So we also need to specify a condition that will say either we have visited that number or not. So suppose for example, we have 1733. So suppose our number is 1733 and we are changing again the second digit. So 17. So we are again changing this 7 to 0, 1033. So and there is a possibility that we can also do this, but we don't have to do this because 1033 was our previous number. So we also have to maintain an array that will contain all our visited numbers that we visited previously. So we don't have to change this 1733 to 1033. So that is so for one digit, so there are total of 4 digits we can place, and for one digit we have total of 0 to 9 values, right? So what can we do now? So if we are changing any number, so suppose we have 1033. Okay, so suppose we have 1033 and we are changing this number. So what can we do? 1030, 1031. So here it is 0. And we can also say 1032 and up to, so there is 012 up to 9, 1039. So we have to check all the numbers either they are prime or not. So when we are changing any digit, so first of all we will start changing from our first digit and we will place all the 10 values from 0 to 9. And for any number, suppose we have this number, and for this number we have to check this should be not visited previously, right? And this should be also prime. So these are the two conditions that we have to check, and we have to find the shortest distance from this x to y, and that is why for finding shortest distance we will just use BFS, breadth first search, and that is using a queue. So that is a simple algorithm that we are going to use, and for these conditions, for so we need these two conditions. So we have to maintain a visited array and also a prime array that will tell us either this number is prime or not. So for maintaining this prime array, we are already given this array, but we don't need it to be an integer array. So we can just write it as a boolean array, and we will just use sieve of Eratosthenes to maintain all this whole prime array. So we will just create this prime array, boolean array, and at one position, at one index, this will tell us either that index number is prime or not. So we have to make an array of size 1. Uh, Yeah, 1, 2, 3, 4. So we have to make a array of size 10,000 because the maximum possible number is 9,999, right? So we will just create an array, and after that, first of all, we will say all numbers are prime. So I hope now you know we did that thing so many times in our POTD series about this sieve of Eratosthenes problem. So first of all, you can just also Google it. This is a very simple problem. Sieve of Eratosthenes. So first of all, we will say all numbers are prime, and after that, we will just iterate from 0, not 0. Okay, we know that 0 and 1 are not prime. So we can also write it as this. but this is not necessary because we will never use this 0 and 1 to check either they are prime or not, so we never need this thing. And after that, what we have to check, we will traverse and I equal to from 2 to less than 10,000 and I plus plus. And if that number is not prime, then we will continue. And if that number is prime, then we will just say all the multiples of this number is now not prime. So we will just start another loop from 2 to I into j. So that is the second method that you can use, and there is also one article in article on that GFG platform that you can use, that have a particular algorithm for writing this thing C operator sign. But this is a second method. This is also a very simple method. So 10,000 and j plus plus. So that means first of all j equal to 2. So 2 into 2 will be 4, and after that j will increase. So j is first 2, then it will be 3, then 4, then 5. So that means 2 into 3. So it is consider it as a table of 2. So 2 into 2, 2 into 3, 2 into 4. So we will just say prime of this I into j equal to false. So that means this number is not prime, which is multiple of I and j. So if some number is multiple of other two numbers, then that means that is the number is not prime. So I into j is not prime, and I hope this thing is clear. 10,000. Okay, and after that we also need one thing. Okay, so I will tell you that the thing later when we need that thing. So first of all, we have all the numbers from 1 to from 0 to 10,000. We can tell every number that from 0 to 10,000 either they are prime or not. So in that prime array, and after that we need the second thing, that is our visited array. So we will also create a visited array that will be also boolean. Boolean array that will be also of size 10,000. And after that, what we have to do? Now we have to do our BFS, breadth per search. So first of all, we have some number x, then we can change one digit of that number, and also we need to find the distance. So from x to x dash, we have one distance. And suppose from x1 to x2, we also have one distance. So we also have to maintain that distance. From 1, then it will be 2. So what is the absolute distance of x2 to x? So it is our initial number, and this is our x2. So we have to maintain the what can we say, absolute distance. So x2, and the distance is 2 from our initial number. So we have to maintain the distance from every number to initial number. And suppose after that we reached our y. So the absolute distance is 3, and we will just return this 3. So x2, x1, and x. So the distance will be 3. So we need two things in our queue. So we already know that thing. When we are using a breadth first search algorithm, then we have to use a queue. So q, and our q will now need two things. First of all, this x, that will be our integer, and second number is this number. So we need two numbers. That is our integer, that is our initially number, and after that this distance. So we need two integer values, and then we will store it in integer array of size 2. Okay, let me just zoom this now. So in q, and that will be our linked list. And after that, first of all, we have to add our initial value, that will be our new integer array, and that will contain now two values. First of all, our initial number, that is num1, and the distance is initially 0. So what is the distance from this number to our initial number? That is 0. So we have to always maintain here the distance from our initial number. And after that, when we are adding that number, so we will say this is a visited number. So first of all, when we are adding some number in our queue, that means when we are adding a number in our queue, then we are saying that this is a visited number, so that we don't have multiple numbers, repetitive numbers in our queue. So after that, while not queue dot empty, and we will just poll. We will just say it current queue dot remove, and after that, what we have to do? So first of all, we need two things. If, so that is our base condition, if current zeroth, so zeroth value is some number, and if that zeroth value is some number is equal to our final number, last number, so that is our num2. So if we have our num2 in our in our current number, then we will just say return the distance, and distance is on first index. So I hope now you know this thing. And after that, what we have to do, we have to now traverse and change all the digits. So suppose our number was 1033. So first of all, we will change this 1 and write all the 9 values from 0 to 9, right? So first of all, we will start from our digits. So this is our 0th index digit. I should be less than 4 because we have total of 4 digits from 0 to 4, 0 to 3. And what is the easiest method of changing some digit in our number? And that is creating that to an string, and then we will just convert it into a character array. So we will just create it into a character array. Then it is the easiest method, I think, to change some digit in our number. So if this is a character array, then we will just change this 1 to 0 and then 1 to 1. So it is already visited, then 2. So this is a new number and we have to check either it is not visited and prime. So after that, it is 3033, then 4, then 5, then 6, and up to 9. So we just have to change it into a character array. We'll just call it ARR, and that will be equal to, first of all, we have to convert it into an string so that we can just directly convert it into a character array. So to string this 0th. So on 0th index, we have a number. So first of all, we created it into a string, and after that, we have to convert it into a character array. So character array, and that is now our ARR. So first of all, we have to place all the 9 values. So from character ch, from 0 to character ch should be less than equal to 9, and every time this ch plus plus. So you can also traverse it like this from character 0 to 9. So we have all the characters, and first of all we have to change one character, right? So first of all, before changing, we also have to store, because if we are changing, then suppose where we change this from 0 to 9, so after that we have to change the second number. After that we have to change the second digit. So from 0 to suppose 1. So it is here 9133, but we need here the previous number was 1 and here it is 0. So when we are changing this from 0 to 1, then we need this number to be 1. So on the first index it should be 1 always, because that was the previous number. So either you can create this array inside this loop, or you can just store previous character, and that is like backtracking thing. But this is a very simple concept, that we don't have to lose our number. That is our initial number, so we don't have to lose that. So first of all, we have to store the ith character. So ith character, and that is not an integer, that is a character. And first of all, we stored, and after that, we have to update it into this ch. So I hope now you got this thing. First of all, we are storing that what is the ith character. So in our example, so in this example, so I is equal to 0. So it is here 1. So we just stored that previous character was 1. And after that, we are changing that character to so ch. So ch is initially 0. So we updated it to 0. And we know previous character was 1. So we also note that thing. So we have to store that. And after that, we have to just change it into again integer, and we have to check either it is a prime number. So it should be also prime number, and it should be also not visited number. So we have to check that condition. So we have to convert it into number, and that will be equal to, first of all, we have to create that character array into a string and then to a number. So that is the thing. First of all, we created that array to a string and then to a number, and that is our new number. So that is 0033. So it is here 0033. So considering it as an integer number, so it will be only treated as 33. So 33 is not a prime number. So that is why we have to not consider it, because it is not a 4-digit number. So that means the first digit should never be 0. So when we are checking it, so we have to only check it if not visited this new number, and this should be also prime of this new number. So this 33 is not visited, and this 33 is also not prime. So first of all, we consider it here as a prime number. So suppose it is here prime number, but it is here 11 and not a 4-digit number. So first of all, in our any number we need 4 digits. So that is why we should not place 0 here at first index. So that is why we have to write here from 0 to less than 1000, all numbers should not be prime. So prime of all number equal to false. So that means we will never enter in this condition. So suppose, for example, if we stuck in this condition that we change our all the numbers and we have 0011. So suppose for this example we have 0011 and that will be as an integer considered as 11. So it is here 11 and not a 4-digit number. So when we are checking in this condition, 11 is not visited and 11 is a prime. So that condition is satisfied also for 11, but we don't need to do that. So we should not consider this condition for our all the numbers that are not 4-digit. So that is why we are writing here this, that all the numbers that are not 4-digit is also not prime. So that is just a condition that we are checking. Or you can also check here that this should be number, this new number should be greater than equal to 1000. Oh, that is also one condition that you can either check here or you can also write this thing. So there are two choices for you, and let me just remove this. So that is a more logical condition that our new number should be greater than 1000 and it should be also prime. So and it should be also not visited. So if that is the thing, then we will say new number is now visited, and we have to add that number. So new number, and okay, we have to add two things to our queue, and they will be our new number and what is the distance. So distance should be current distance plus 1. So first of all, initially current distance was 0 plus 1. So current distance, that is current 1 plus 1. So I hope now you understand this thing, because that is the previous distance. So that is the thing we were talking about. So here to reach our x2, so here to reach our x2 we have to first of all get the previous distance. So what is the distance from x1? So let me just show you here clearly. So to get the distance up to x2, we have to first get the distance of reaching x1. So what is the distance of reaching x1? Here it is 1. And we will just say for reaching x2, the distance will be this one plus 1. So for reaching x2, the distance will be 2. So x was here. So for x, the reaching distance was 0 because x is our initial number. And for reaching x1, we have this 0 plus 1. So that is the thing. I hope now you understand this. And after that, in this problem, so we have to now backtrack, and backtracking means we have to replace this number with our previous number. So we have to place here 1 again, and here it was um, something. So character I is equal to previous character, and that is here our backtracking thing, and that is just we have to do to get our previous number. So that is it. And I think at last we have to return -1. So if we never reached from num1 to num2, then if there is no path, then we have to return -1. And if in any case we reached our number 2, then we will just hit in this condition. So we will just hit in this condition, and then we will return our distance. So let me just try run this thing. So we have 1 0, I think it is 37. So let me just check this. So it is here 33. So we have 1033. And after that, first of all, we will just get this 1 and replace all the numbers from 0 to 9. So first of all, we will just place 0, then 1, then 2, up to 9. So that will be not considered as our prime numbers. And after that, we have to replace all the zeros. So first of all, we will replace this 0 with 7. And for reaching this number, the distance will be 1. And after that, after another iteration, we will just remove this thing also. So we will just remove 1733, and first of all we will replace this 1, then replace this 7, then replace this 3, and yeah. So for when we are replacing this 1, we are replacing it with 3. So 3733. So for reaching this number, we have distance equal to 2, and after that 3733, we have 3739. So first of all we replace this, then 7, then 3, and at last this 9. So when we are replacing this 9, we will replace this 3 with 9. So the distance will be 3, and that is it. So that thing will be also added to our queue, and when we remove it, so we will also replace this 3 with 7. So the distance is here 4 now. And after that, we will just replace this first number with 8 and this second number with 1. So we changed two places, so the distance will be 6. and at last we are returning the distance here. So we reached our final number and we return the distance. So that is it about our algorithm. And you can also do this thing in our this function, but when we are creating our function, it is a good practice to initialize our prime array. So the time and space complexity. So when we are doing this thing, so when we are doing this sieve of Eratosthenes, the time complexity n into log of log n. So that is obviously less time than n log n, and the space complexity is O of n for this visited array and for this queue. So that is it about today, everyone. If this video is helpful, go hit the like button and also must subscribe to our channel. Already 80% of the viewers are not subscribed to this channel, so do subscribe to our channel, everyone. And let me just now paste the solution to our DS repository. So if you want any solution of GFG or lead code problems, then you can just refer to this repository. Also, you can contribute your solution to this repository, and also don't forget to star this one so that you don't miss this. So I will just paste the solution here, right? And thank you for watching.